Okay, it's a 1:15. Welcome back, everybody. I see the number of participants rising quickly. We went up to, I think, from 260 now to over 300. So I'll wait a few more moments until more people have joined. The good news is that registrations even continued during the morning session. We are now at 620 people registered. Um, so that's quite a high number. That's more than we could host in the hotel last year. The good news is that next year we hope to be again back in the hotel in Brussels. I propose that we start. There are not that many pitches. As you can see, only 11 pitches. That will be one a long video. Directly after the video has ended, the breakouts will open, and that will be visible by the four small squares down on your screen. Yeah, there's a question why the numbering is different. This is simply the sequence of numbering in the video. This has nothing to do with the ECT tool at this point in time. Okay, then I would like to invite Arjan to start the video. Then I will stop my video and
Hello and welcome to AgrarSense. Do you eat carrots? You want more than one? You want it grown organic? With less manure for a better economy of agriculture? And when we speak of less climate gases would also be nice? Well, welcome to AgrarSense. We want to bring the benefits of microelectronics and photonics to agriculture. We will do this in form of sensors and actuators which we want to integrate on a platform. This platform is mounted on a farming vehicle or a drone or placed in a greenhouse. The microelectronics and photonics sensors are able to measure a variety of important parameters for plants in the air and the soil. These parameters could be mineralization of the soil, humidity in the soil, volatile organic compounds known as VOCs around the plants, and the sound of insects. A smart integrated algorithm creates a map of the measured parameters and derives locally necessary actions performed by actuators like sprayers, for example. With such a powerful platform, AgrarSense opens the way to a sustainable and environmentally friendly food production. Economics of agriculture can be optimized by minimizing the use of fertilizers and pesticides, while in parallel the impact on climate is reduced and biodiversity is preserved. What are our technical goals to create such a versatile platform? We will develop new sensors to measure soil humidity, mineralization and fertilization needs. VOC sensors are integrated and analyzed by an artificial intelligence to determine and predict the health status of the plants. New technologies will be raised to measure insect population and thus support biodiversity. Sprayers will be developed to apply locally fertilizers and pesticides. These new sensors and actuators are integrated on a platform to be mounted on drones, farming vehicles, forest vehicles, and in greenhouses. AgrarSense promises a lot of important impact on the agricultural landscape and our environment. The efficient use of fertilizers and reduction of pesticides goes hand in hand with a more energy efficient way of running agriculture. This also has a positive influence on the environment and will reduce the emission of greenhouse gases. The farmer will benefit from an improved economy. New sensors and products will enter the market, produced in Europe for European needs. These innovations will come along with new value chains, higher competitiveness, and new business for a stronger European economy. Who is AgrarSense? The core team consists of the CSEM and 2 institutes from Frauenhofer, IZM and EMFT. We also found some partners which confirmed their interest. These are the RTOs CELT, VTT, UWB, Tyndall, IMMS and Agroscope. As large enterprises, we could win ST Italy and ST France. What are the partners we're looking for? We search for end-user companies dealing with farming vehicles, fertilizers and forestry vehicles. As technology suppliers, we need drone companies, precision agriculture companies and sensor companies. We are heading for a KDT project, the successor of Axel. If I could draw your interest and you want to be part of a project which takes care that enough of these grow in a sustainable way, contact us by writing an email to agrarsense@fraunhofer.de. Thank you for your attention.
Hello. Today I'd like to talk to you about a project concerned with taking data from a single sensor, or more normally multiple sensors, processing those data and then presenting them out to an external interface for additional processing or for consumption by an end user. The project is called SeDMO, which stands for Sensor Data Management Optimization. If we look a little more closely at this contemporary reference architecture that I'm sure we can all recognize, there are a number of elements which are instantly identifiable. First of all, we have the sensors, which collect the various data from the outside world, and those data are then delivered, hopefully over secure links, to a processing environment where they are processed and turned into useful information. That useful information is perhaps stored there, and then it is delivered to an end user or to a further processing environment. The intention of SeDMO is to develop the techniques and technologies to optimize these type of sensor network in a world where there will be many, many more sensors, and those data will be carried over many, many more networks, and there will be many, many more security risks and malevolent actors who are trying to compromise the system. On the sensors themselves, we will have new challenges over uncollaborated data through to different claims on availability, reliability and accuracy. We will also have more of them. So we will have to be able to perform native processing. We will have massive multiplicity to deal with. Self-diagnosis and fault detection will be essential, and we will need simplified provisioning models and in-field update. We will also need to deal with lifecycle handling and BIS-BOSS procedures, which we don't really do in a standardized way today. On the sensor devices, we are going to have to move the processing from the concentrator or back-end processing devices towards the individual sensors themselves, simply because of the multiplicity issues, and also to reduce the network loading. So when we do this, we are going to find an increased emphasis on low power operation. We are going to want to be sure that the algorithms that we were running in the back end can run correctly on the endpoint devices. And ideally, we would like to encrypt those data as early as possible and keep them encrypted while we are processing them. So there's, even if the endpoint or indeed the rest of the system is compromised, the consequence of that compromise is limited. We also need to be able to do debugging and scenario reconstruction to understand what went wrong when something has gone wrong. And it would be very, very nice if we could label the data in such a way that we can do event correlation across multiple sensors or endpoints. Finally, being able to configure when the sensor sends information to the back-end system in a standardized way will make life a lot more straightforward. For the communication links and the endpoint security, this is obviously key, because if we compromise the endpoints, potentially we have compromised our entire system. So standardized mechanisms for key distribution and management, mechanisms for compromised device recovery to be able to get a device back into operation once it's been recognized as having failed, are essential. We need, to be honest, the communication standards and protocols already do exist, but we have to adopt and extend them a little bit to make them compatible with an open architecture. And then best practice and understanding how we can mitigate against physical attack resilience, because when these things are out in the field, they will be attacked. And finally, detecting when we have been compromised. Storage suffers similar constraints to processing. As we develop more and more nodes, then it becomes more difficult to do it centrally. So we will start to want to distribute it to the endpoints. And when we do that, we will want to be able to query those data from that endpoint remotely. So we will need data labeling and remote query capabilities. We will need to be able to dispose of that data at the end of its life. And we will need to be able to prove that it was correct and that it has been recorded correctly and that it has not been compromised or meddled with. Further, we need to be able to lossily compress it when necessary, retaining certain features of it. And we also need to be able to cache it and transparently access it from a back-end system. The final element of all this is presentation, where we have to make this stuff available for developers to use, which requires abstraction, APIs supporting multiple languages, libraries and documentation, tooling and algorithms, and dashboards, device management, things of that nature. And then we have to do the outreach and the socialization to make it work in the real world. So where we are, we will make it easier to build secure, reliable, reusable and performance sensor networks, and it will prove those techniques in practical use cases. We have the use cases identified, we have sub-consortia, we have Dutch grouping already complete, we have German, Turkish, Canadian and Finnish groupings to some degree complete, depending on which one we're talking about, and more national groupings are welcome. Technical contributors to each of the work areas may still be admitted as the space permits in the program and funding is available. And project management and administration services have been secured. We will submit to Penta on the 26th of February 2001. And that is an outline of SeDMO. If you would like more information, please drop me a note.
Hello, my name is Jasmin and I will be presenting our project idea of using Edge Continuum as a backbone for new digital economy system. The main motivation for our project idea is the fact that if we want to keep improving our economy, it is necessary that we keep increasing manufacturing of products. However, the problem with manufacturing of the physical products is that it's bad for the environment. The second problem is, as we keep increasing the number of robotic systems in manufacturing, especially in the Industry 4.0 era, the question is then what is really the role of humans in manufacturing, as we keep automating repetitive tasks. In order to tackle these two problems, we suggest to focus on manufacturing of digital products in terms of personalized digital services and customized digital products. Personalized digital services and customized digital products are nothing new. However, only those workers with strong competences and expertise in software engineering are able to create this. The question is, how can we enable people with no software engineering expertise to express their other expertise and their creativity in digital world? Any solution which aims to solve these two challenges, to answer these two questions, needs to solve the following challenges. First of all, it needs to solve the challenge whether it's possible to give value to wide spectrum of digital products. The second one is, how can it enable manufacturing of digital products without software engineering expertise? As a potential solution to these challenges, we see the usage of edge computing technology. First of all, it's close to the customers, whether these customers are customers in industry manufacturer environment, whether these customers are customers in public services and public administration or in retail. And the second of all, it's a good basis for creation of customized digital solutions. However, there exist research and practical challenges. In terms of it's necessary to create platforms and ecosystems which rely on the existing technology stacks and which provide tools for the creation of new products. So not anymore means for creation of the tools, but tools for creation of a wide spectrum of digital goods. In order to do so, it's necessary to enable and create infrastructure which gives value to these products. For example, if we would not have roads, most of our cars would lose the value. We need to do the same thing for digital goods. The second question is how to create these tools that enable manufacturing of digital goods. And the final thing is how to adopt, adapt, and improve existing concepts for monitoring and testing of behavior of digital services somewhere in the background of these platforms. As a potential economical impact of our project, we see creation of a new digital infrastructure with the focus of the edge computing. We see also creation of new digital goods that will result in creation of new jobs, of reduction of our carbon footprint, and in reduction of manufacturing of physical goods. We have several partners which are already helping us with these efforts, but in general, we are open for welcoming new partners. Especially, we are welcoming new partners in the domains of manufacturing, whether these partners want to improve their manufacturing processes or they're aiming to create new ecosystems for others to create, do manufacturing of digital goods, the public sector, medical sector, or any other sector which requires customized solutions but has issues with privacy and is limited with the current limitations of cloud computing, and retail, as we aim to create circular economy in terms of digital goods and digital services. Especially, we are welcoming use case providers in this application area. We are welcoming technology providers in terms of software system architecting of ecosystems and cyber-physical systems, digital economy experts. We are welcoming virtual prototype experts, experts in terms of digital twins, experts in AI solution, and experts that are providing AI solution platforms. If you're interested in joining our project, or if you're just interested in order to see how this project will develop, we recommend you to subscribe. Thank you for your attention and looking forward to your questions.
Hello, and welcome to the presentation on MedCoach, Medical Autonomy for Deep Space Missions. My name is Andrew Gagnon, and I'm with the ADGa Group. A brief overview of who we are at the ADGa Group. We are a privately held Canadian corporation that has celebrated over 50 years in business. We are headquartered in Ottawa, Canada, with offices in Gatineau, Toronto, and Montreal. We have further satellite offices in Kingston and Calgary. We employ over 700 employees and consultants and possess industry standard certification, such as ISO 9001. We further maintain security clearances on personnel, facilities, storage, and processing up to the top secret level. The motivation behind MedCoach. Deep space exploration missions will see humanity travel further away from our planet than ever before. Medical help from a mission control center will no longer just be a phone call away. And the laws of physics will impede a crew's ability to obtain help in a meaningful way. Consider the 14-minute communication delay between Earth and Mars. Certain medical conditions need immediate intervention and will not tolerate any sort of delay. For other conditions, early intervention can improve outcomes significantly. Crew medical officers and minimally trained crew members will need support in the event of medical occurrences. The challenges we wish to address through MedCoach. Astronaut pre-flight medically focused training is very limited. Many crew members do not have a background in medicine, and the time between skill acquisition and skill use may be quite long. In the case of a mission to Mars, we're looking at months to years. Therefore, skill fade is of significant concern. The objectives we wish to address through MedCoach. Just-in-time training and real-time guidance. Skill acquisition or skill refresh is needed immediately before or at the time of need. We need to focus on acquiring the skills needed when the need is identified. Some medical care can be scheduled. However, emergent care necessitates immediate response, and learning in the moment may be needed. We wish to provide real-time, real-world procedural guidance. Medical guidance requires that the care provider be able to interact with the real world. Guidance therefore needs to be enhanced using augmented reality techniques. The MedCoach project aims to address these issues by providing hands-free, just-in-time training and real-time medical guidance by leveraging computer vision and augmented reality to provide operators with the skill sets required at the time of need. The technical goals we wish to address through MedCoach. Expand the state-of-the-art medical AR landmarking techniques. integrate computer vision for object recognition to assist with the identification of medical instruments in human anatomy, allow configurable levels of medical guidance based on operator needs, and implement a hands-free, voice-controlled application guidance. We wish to further standardize a format or schema for medical guidance procedures. The impact we see from this project. The end result is an AR-enabled, voice-controlled headset providing medical guidance and just-in-time training. We see use cases in both deep space and terrestrial applications, such as in the case of remote communities or disconnected environments. We wish to reduce healthcare provider stress and help improve patient outcomes, as well as contribute to a greater understanding of the role of AR and ML techniques in the medical domain. We are currently partnered with Leap Biosystems. This is a Canadian space and medical specialist group, including former Canadian astronaut Dave Williams. We are currently looking for partners and consortia from additional countries. If you are interested, please don't hesitate to contact me. Thank you.
Hello, my name is Ciprian and I am presenting today our project idea, acronym DT for Cosmos. The aim is to develop collaboration methods, swarm behaviors, for heterogeneous manufacturing devices using digital twins. With the advent of Industry 4.0, the production systems have potentially become ready for customization, adaptability, and flexible reorganization. It advocates the employment of many heterogeneous devices that cooperate without any central control and act according to simple local behavior rules. By their collaborations, a collective behavior emerges that can solve complex manufacturing tasks as a kind of quasi-organism that can adapt to changes in the environment. What are the technical goals? To develop methods and tools to generate digital twins for manufacturing devices using AI capabilities for perpetual learning. To develop methods for an appropriate representation and generation of the environment or infrastructure. To develop basic swarm behaviors for spatial organization, navigation, decision-making, human-swarm interaction. Swarm behavior emerging from local interaction is hard to predict and inappropriate for testing in industrial context. Therefore, analyzing swarms requires suitable simulation that integrate and execute the digital twin of each device from the target system. Moreover, these digital twins embed heterogeneous models like computational, physical, electrical, that are developed with different tools. The impact will be in energy consumption, predictive maintenance, resilience and agility in case of unexpected events, improved human control of system from system to system of systems. A first testbed for this project can be an adaptive production system prototype. It has a complexity close to that of a real system manufacturing. It consists of 8 workstations, which can be placed as needed, and the flow of the material is provided by a fleet of autonomous guided vehicles for the assembly of the product, which in our case is a modular tablet. 2 collaborative robots are foreseen to enable the collaboration with the human, both at loading the semi-finished products in the system, as well as at its completion at the customer's order. The prototype allows a distributed control of industrial control equipment, like PLC, and its execution is based on the IEC 61499 standard. A multi-agent system allows the execution of customer's order according to the rules set by the line manager. Relevant projects for DT for Cosmos are listed here. The digital twin topic is tackled in DigitBrain and Hubcap, digitalization and automation tools for manufacturing in Arrowhead Tools, human-centered cyber-physical systems in the Difficile project, and finally digital design skills for the factory in the DigiFOV project. The current consortium entails partners from Romania. Propardo is a digital technology provider. Lucian Blaga University of Sibiu is a top university in the center region of Romania. Smart Factory Romania is a non-profit association that focuses on the adoption of digital technologies in manufacturing. and we are looking for partners from industry, research and academia interested in the presented topic. Key expertise areas are digital twin, coordination and control of systems such as autonomous guided vehicles, design of systems, as well as relevant manufacturing test beds for swarm applications. So if you are interested in working with us on our project idea, don't hesitate to contact us. Thank you very much for your attention.
Hello everyone, I'm Holger Blosum from Esko, and I'm presenting the Mohsadha proposal about modular hardware software architectures for demonstrable high assurance embedded systems. So the problem is a well-known one, all kinds of embedded systems, here some from the traffic domains, need trustworthiness for the entire system down to the hardware. At the moment, hardware is often a black box, so see Spectre meltdown attacks that have been shaking the world not too long ago. And the idea is to build resilient hardware software architectures that have a small core that can be demonstrated and inspected, and to show this by different demonstrators in different domains. So what we at Esko can bring in is our separation kernel. So that's the blue thingy here in the middle that gives you modularity and different application domains, and it's interacting with hardware with demonstrable assurance. Here we are thinking of RISC-V based architectures, for instance. Our separation kernel brings all the certification that you will need for mixed critical systems, and on this we build high assurance systems. So the expected impact is that there are new platforms that are using an open hardware and separation kernel stack, and as take home for the users, I also would expect that the platforms are certification ready. So it might be a good idea to combine this with some certification plans or exercise that you're going to do. So for the needed profiles, well, we are providing the separation kernel, the operating system, the embedded operating system. So what we need above is use case providers who actually have need for such a high assurance architecture. And on the hardware side, we are interested in contact with hardware providers of appropriate platforms, partners, primarily industry. Thank you.
Ladies and gentlemen, I'm Juuso from University of Oulu, Finland. Our project ADLPD for CPS stands for Advanced Deep Learning for Big Data for Cyber-Physical Systems. So our challenge here is in these research and development silos. So deep learning includes many methods, AI, IoT, cloud computing. They are proposed for heterogeneous datasets and are not sufficient for technical systems. Big data also includes many methods for measurements, waveform signals, spectral data, images, and sparse performance indicators. They require specific feature extraction methods before using in the analysis. So we aim to conduct compact solutions by combining these two silos, and these need to be integrated and adapted to the market needs. The systems operate in changing operating conditions. Situation awareness is there important for risk analysis and decision support. So our technical goal is advanced solutions for CPS. So there we need advanced features and compact indicators and linear interactions, and also temporal analysis. The whole system is done with a parametric approach. So we combine data, models, and domain expertise. Applications are developed gradually for cyber-physical systems, and all these can be recursively updated. Machine learning is there also for deciding what we are changing, when, and how. So result is integrated set of products for measurements, data analytics, IoT, and automation. And these two boxes aimed for building cyber-physical systems with an increasing level of autonomous systems. SMEs are very important, so they can get the new application areas, sales and patents, and customers are integrating these things, and they need integrated solutions and improved situation awareness. And then, of course, research institutes, publications, patents, and spin-offs. The expected duration is 36 months, and we aim for specific compact solutions for market needs. Our partners have case-specific variations. So we have large customers on different areas. We have measurement developers. We have intelligent analyzers mainly connected with research institutes, and then also control and optimization and IoT to connect these different things together. Here is an example of a case. So this is an industrial case, and there we have use interactions with the existing systems, and we add their condition monitoring through edge computing, which is important there, and image analysis to the collected data, and data pre-processing is there, and this advanced deep learning is using these informative indicators, interactions, and domain expertise, and intelligence systems out there. So we developed smart services for real business needs, and these aim for wider cyber-physical systems in time. Thank you for your attention.
Good day, everyone. This is Hussam Kenawi, Chief Scientist and co-founder of Wedge Networks. It's my great pleasure here today to present to you the absolute real-time threat protection for smart infrastructure and smart buildings proposal. This proposal is fronted by Wedge Networks, representing the Canadian consortium, as well as the gentleman Mohammed Salih Setin of Mavinci, representing the Turkish side of the consortium. In a nutshell, what we're trying to do here is we find a lot of challenges with smart buildings, and in fact, technologies such as artificial intelligence, IoT, and 5G networks are making these smart buildings smart, but they're also making them open and vulnerable to physical and cyber attacks. Our goal in this project is to eliminate these smart building vulnerabilities through this proposal. The objective would be to address and provide solutions for intrusion detection, anomaly detection, and most importantly, real-time threat protection, such that these systems can protect themselves against cyber and physical attacks, or especially for critical facilities, such as government departments, financial or military buildings, as well as our public areas, such as airports, sports facilities, industries, and so on. In this project, we have a very specific target. Is to provide a real-time building management system that can protect the building against cyber and physical attacks, ensuring that we have safety when it comes to public area buildings or mission critical buildings. And of course, we would like to establish the cause-effect relationships when it comes to suspicious situations inside and outside the building as well. In so doing, we'll be building an artificial intelligence platform for building management systems, would basically go in and do the deep learning schemes for determining non-conformities and hence providing this level of protection. That being said, the focus is to establish an effective real-time security solution. That's the most important key point. It has to be real-time, otherwise these buildings will continue to be vulnerable. We will combine transport technologies like 5Gs, IoTs, as well as AI to provide the data fusion for the security of these infrastructures. And then most importantly, we will have basically what we call as orchestrated anomaly detection for these buildings. We will deploy deep learning techniques, and more importantly as well, what makes this proposal quite unique is that we will also go in and monitor and detect RF signals, simply because we are starting to notice that RF, specifically when you have everything based on Wi-Fi or Bluetooth or Zigbee, you can have RF-based anomalies, and you can actually have cyber attacks coming through RF. So here are some of the technical goals very quickly here. In the physical security, we'll basically look at things such as behavior detection, crowd counting. When it comes to cybersecurity, we'll look at things, as I mentioned, the wireless connectivity, have the complete security picture and posture, right? And also put the AI so that we have, through extensive training, detect possible anomalies in the operation of such buildings. So we will not just focus on typical transport systems. We'll also look at things such as wireless RF security. So we'll look at things such as spectrum hijacking, jamming as well, because as we mentioned, all of the infrastructure is based on wireless nowadays, and ensure that we have a wireless security being part of the complete and comprehensive system. Then finally, we develop techniques when it comes to anomaly detection, as we speak about them here. For example, the orchestrated anomaly detection is a novel concept, also extending things such as RNN and LSTM algorithms for these systems. And then, of course, the approach, which is basically the digital twinning, right, with the physical and digital systems, and ensuring that we have both of them to ensure that we can have the digital model giving us the predictive operational models, as well as detecting any kind of anomalies, ensuring that we can combat it in real time. We do believe the economical impact to be huge. In fact, in 2021, half of the industrial companies will be using digital twins to gain at least 10% improvement in effectiveness. But more importantly, we believe that this is quite critical for our quality of life, our safety. The duration is, as mentioned here. And then finally, we're looking for partners. We're looking for partners that are EU-based, smart city solution providers, IoT solution providers, system integrators, industries, SMEs, universities and research institutions, as well as AI learning algorithm developers. If you're interested, please get in touch with Mr. Osama Sharaf, as well as Mr. Mohammed Saleh Sitin. We look forward to hearing from you. We look forward to your participation. Looking forward to your cooperation. Thank you.
Good afternoon, everybody. My name is Mike Hayes from the Tyndall National Institute in Ireland. I would like to discuss with you today the concept of Lollipop, developing long-life power IoT solutions for predictive maintenance. Our main objective is for us to develop energy harvesting micropower management solutions for wireless IoT edge devices, enable us to retrofit sensors to undertake condition monitoring for predictive and preventative maintenance on, in or near equipment and infrastructure for Industry 4.0 applications. There is huge potential out there for retrofitting such sensors for anomaly detection and for efficiency and performance monitoring. However, the typical battery life for such sensors is of the order of 12 to 18 months, and in many cases the downtime, cost, effort and logistics associated with replacing batteries makes this commercially unviable. On the other side, significant factory savings are possible by applying predictive maintenance algorithms based on the wireless data collected. So the technical goals of Lollipop then are for us to develop multi-source energy harvesting solutions so we can convert ambient energy such as indoor light, vibrations and heat to electricity and extend the battery life. And this will comprise technologies such as PMICs, discrete ancillary circuits, various types of digital interfacing and innovative architectures, and last by no means least, some simulation models. Here is a visual implementation of the Lollipop concept. We start with the use cases that we have in mind based on predictive maintenance algorithms that we want to develop. We then identify what types of wireless IoT edge devices we need to create in order to gather the data. This will comprise microcontrollers, sensors, transceivers, and wireless architectures. We then figure out how do we actually power these wireless IoT edge devices using energy harvesting and power management technologies. And finally, we develop simulation models so that we can understand and optimize the power consumption of the IoT devices, and we also understand the ambient energies that are available to us and how we can harvest and store such energies. The potential economic impact of Lollipop is considerable. It has been shown that maintenance costs range between 15 and 40% of total production costs, and predictive maintenance can save between 8 and 12% over preventative maintenance and up to 40% over reactive maintenance. Also, $50 billion is annually wasted on unplanned downtime. In terms of the budget and project duration we have in mind here, we have around 36 months in mind and a project budget of between 5 and 9 million if it's a standalone project. But we are also open to the prospect of it becoming a subset of a larger project, for example, that delivers reliable retrofittable power source and data collection systems. At present, the Lollipop Consortium is being spearheaded by ourselves at the Tyndall National Institute, but we are actively looking for an industrial partner, preferably one of the use case owners, to coordinate the project, and we are also in addition looking for 1 or 2 more use case owners. At present, we are creating several subclusters around the various use cases, and these use case owners will have a major say in who is selected from the various people who've already expressed interest. We are already oversubscribed with technology partners. The full list of interested parties will only be shared for now with the use case subcluster owners. And we are already in discussions with several partners at present, and details will be announced based on areas such as predictive maintenance, algorithm development, ultra-low power microcontrollers and transceivers, energy storage devices, and low power wireless communications. Finally, some additional information for those of you who are unfamiliar with us in Tyndall. We are a leading technology and thought leader in developing power IoT solutions for academic and industry partners, developing things such as power management ICs, discrete power management solutions, ultra-low power IoT edge devices, simulation models, and power supply in package and power supply on chip embedded solutions. We also lead many collaborations creating power IoT ecosystems. This includes NRHARV, a biannual Power IoT workshop that's organised by PSMA, the EU Enables Research Infrastructure Project, which we coordinate, and we're also very actively involved with PSMA in terms of their Energy Harvesting Committee and development of technology roadmaps. That's it, folks. So I would appreciate any feedback from anybody in the audience who would be interested in discussing this further regarding Lollipop, or indeed any other collaboration opportunities you see for us to work with Tyndall. Thanks for your time and attention, and goodbye.
Hello, everybody. My name is Joshua Wallace from Nanolit Technologies, and I've come here today to speak on the applications of quantum dots for non-visible satellite imagery. Some challenges and objectives for us are to improve the calibration of satellite sensors in order to generate a 94 to 97% rate in imaging data. This is something that's lacking in the current satellite industry, as the error rates are approximately 10 to 15%. This will be done by both increasing the available calibration bandwidth produced by emitters and greatly increase the resolution achievable by this calibration tool. Quantum dots theoretically have this capability, and our goal is really to develop the chemistry involved, as well as acquiring the appropriate peripherals and then putting together some subsequent physical prototypes. The physical prototype will take the scope of a 10 by 10 centimeter light panel, which will produce emissions in both the near and shortwave infrared light from around 900 nanometer to about 2.1 micrometer on the high end there. In terms of technical goals, we're aiming to develop custom chemistries for quantum dot synthesis, facilitating the specific wavelengths we are after. These quantum dot nanocrystals operate by modulating and shifting the spectrum of light entering them to a different spectrum coming out as a function of the nanocrystal size. This mechanism produces a new peak at a specific wavelength that can be predetermined by your chemistry. This peak can be very pronounced, producing a very distinct full width at half max profile on the output, allowing for precise control of emitted light for calibration's sake. There are no off-the-shelf chemistries that exist for the shorter wavelengths that we're after, these IR targets, that is. However, we bring our specialty in quantum dot technologies from our involvements in prior chemistry development, quantum dot synthesis, and quantum dot product development to this table to facilitate this whole process. The calibration tool resolution target is that of a 10 nanometer band, which should be achievable given the pronounced full width and half-max characteristics of quantum dot emitters. That is, however, a secondary objective for us, the primary being that the development of a large bandwidth range is fulfilled. In terms of economic impacts, I want to reiterate that the current satellite imaging error rate is 10 to 15%. From some discussions we've had with other companies who have expressed interest in this technology, we come up with some numbers. Say if we reduce the error rate to 3 to 6, as we are projecting, we would have an estimated 500% market growth, as well as opening the door to some novel quantum dot studies, as well as publications, opening those doors for further science and research. Now, as for applications that impact that 500% growth figure we just mentioned, there are things like natural disaster mitigation and recovery, agriculture, military applications, space exploration. And now is a really exciting time to be developing space-based technologies, given the lunar gateway, the lunar missions that are planned. Many people are trying to force the issue on Mars in the short term. Just overall, it's a very exciting time from a futuristic point of view to be looking at these kind of technologies. And to wrap up, we have our partners that we have currently secured. We have some interest from the Canadian Space Agency in supporting our endeavors here in developing this tech. We brought on nanostructure chemists to assist in any snags we come up with creating those nanocrystal quantum dots as we venture into some sort of untapped chemistry environment for the technology, essentially. There's also 4D Labs, which is a university-owned facility, which we have contact with and access to, which is a MEMS and semiconductor fabrication facility. In terms of technologies or collaboration that we're seeking out of ECS here, is encapsulation technology specifically, as well as aerospace grade electronics technologies and experience. And with that said, I would like to open the floor and say, are there any questions? And we'll see how we can answer these. Thank you.
Hello, I'm Dag Osvär from Spacemetric, a small Swedish company specialized in image data management. Bear with me while I share my screen. Right, there we go. Right, Bluestone on board. That is a combination of hardware and software. Bluestone in itself, it's a software, and the combination is when we put Bluestone on a mini computer. This Bluestone gives a user the experience of having the data on one or many platforms in space or aerial using very little bandwidth. This is a game changer, really, because these platforms generate so much data that it's sometimes not even possible to send it all down. And there's a time aspect also. Maybe you want to start with a really important data. That is what we do. So our project will comprise a couple of steps. First, put the Bluestone software on a mini computer. We're already working on that. Then to put the combination hardware software on board UAVs or airplanes, for example. And here we are doing things in a project for the European Space Agency, soon to be commercialized. And then to put these hardware software combinations through tests to space qualify them, and then at the end put them onboard satellites. This is what it looks like. Sensors, upper left, lots of stuff in the archive, not so much capability of sending things down. So the user from the Earth understands what's available and selects it. This we do by transmitting an overview image and metadata. So these are the technical goals you will recognize from a preceding picture. To put Bluestone on a mini computer, to fly the combination on UAVs or airplanes, for example, to make sure that the combination can survive in space, and then to put the hardware-software combination, Bluestone on board satellites. The project outcome then will be Bluestone on board, this hardware-software combination, and possible to place freely on UAVs, satellites, whatnot. For the customer, this gives a very rapid understanding of what's available so that the priority data can be downloaded first, and the other data maybe never or later. The business impact, of course, this will lead to sales of these hardware software units and sales of UAVs and satellites with these units on board. And societal effects, we think, are very important. This will be very good for blue light authorities, typically having being in a hurry to make sure that they can get the priority data down very quickly so that they can start their important work. Maybe we will do this for 2 months. And I say maybe, we're discussing with partners, so the scope is not certain yet. And we could also include AI aspects. Indeed, we are doing some work with placing AI on board, to place intelligence on board UAVs already. So to sum up, the problem is there. Too much data, too little bandwidth. The problem will not go away. And the Bluestone on board is a good solution. It allows the user from the ground to understand what's available and to choose the most important data for priority download. And we hope this will be a world standard. Thanks a lot.